Hello, and welcome to the Trepa Technologies Security Plus course. My name is Johnny Bandon, and I will be your instructor for this video series. This video will cover Domain 3.7, Secure Identity and Account Management. Now let's get started. An identity provider is a third party that provides identification and authentication services for other organizations. Common identity providers are Google, Apple, and Facebook. An attribute is an extra information about an identity, like name, age, location, or department. Attributes are common in an Active Directory deployment, where you can assign multiple attributes to a user or object in Active Directory, something like their location or their phone number or email, right? A certificate is used in identity management to prove a system or user is authentic and ensures the integrity of a user. Certificates are typically implemented when you deploy a public key infrastructure in your environments. We will discuss PKI more in detail in later videos. So you can see right there for your identity provider, something else we want to go over before we move on. It uses something called OpenID, right? That is a concept for using federated services for authentication, right? This is a protocol for that. But we also have SAML, which we'll talk about in later videos as well, that also do authentication and use identity provider. Sometimes it gets a little muddy in the Security Plus exam objectives on what they want you to think an identity provider is, because sometimes they relate it strictly to OpenID, and sometimes they mean it just in a general or broad sense that a company is providing you authentication services and the protocol they use is irrelevant to describing what that identity provider is. Okay. So for the exam, just know an identity provider is something that provides service authentication and authorization services. A token can be used to authenticate a person's identity electronically. A token can be stored on a portable device like a smart card or even a token, put that in quotation marks, right? That is something people refer to as smart cards as well. Tokens will use some form of certificate for authentication. So tokens are also used in a PKI infrastructure or a public key infrastructure. SSH keys are going to be used when we're doing SSH connections, right? So when we have the SSH terminals in our cloud, we're going to use SSH. And SSH uses RSA keys. And then smart cards. So smart cards are physical cards about the size of a credit card with a chip embedded into them that acts as a security token. Enterprises implementing PKI into their environment typically issue smart cards to their users. So example of this, the DoD, they use smart cards and we call them common access cards. And they are used to log into government systems and are also official federal identification cards. So smart cards can be a lot of things, right? But in terms of tech, see that chip right there? That's what's going to host our digital certificate or certificate to authenticate us, the user. Let's go into account types. As security administrators, we must understand the different account types that may exist on our network and what their purpose is. A regular user account is given to employees to perform their daily duties. A user account should have no special or elevated privileges. Shared accounts are accounts that multiple users will use. A shared account can have the same privileges as a regular user or an administrative user, and they can be shared among, let's say, an IT department or administrators with the same level of responsibility. For example, suppose you have a team of 4 junior database developers. So you got 4 junior devs that work on this database. In this case, they could all use a shared account since they all have the same privileges on your organization's databases. This shared account will be accessed from their regular user account, so you can still track which user is making changes using the shared account. Because you don't want a situation to arise where fingers are getting pointed when the database goes down, right? So there's still a way with shared accounts to have some sort of accounting for who made a change, right? Or logging who did something on a system. And then we have a generic account. A generic account is an account that comes standard with a system, like a Windows local administrator. The generic account should be disabled for most systems if you integrate that system into a domain or your enterprise. If a system is air gapped and not part of your enterprise, you may need to keep the generic account enabled because it may need to use that generic account for administrative purposes. This really all depends on the situation and the appetite or risk for the organization. A generic account doesn't actually have to be a local administrator Windows account. It could just be the basic one that comes with an IoT device, right? And then a guest account is provided to temporary users. They'll have limited privileges, and usually a guest account will have nothing linked to an individual, right? And then we have a service account, which is used for applications and services running in your enterprise. A service account can be created to run a single task for a service. A service account can also have elevated privileges if needed for running this task. Sometimes on our network monitoring tools, we'll create like a SolarWinds account that's going to be the account used to log into all of our network devices or something similar to that, right? Now let's go over some account policies. So as security administrators, we must also implement different policies for our accounts. These policies can harden our users' accounts and make our passwords harder to crack or brute force. Password complexity is used to help prevent brute force or dictionary attacks on our passwords. This will set the minimum requirements for creating a password, like how many unique characters and uppercase or lowercase characters can be used. A password history policy is also used to protect against dictionary and brute force attacks. This policy will not let a user reuse an older password within a specified amount of days. For example, you may set a 90-day password reuse policy, essentially saying that if you use the password within this past 90 days, you cannot use it again. And then we have access policies or schemes, right, that define how users will be granted access to enterprise resources. For example, your enterprise may lay out which departments have access to specific enterprise applications. So when you onboard a new engineer for the research and development department, you can reference your access policy to determine what privileges should be given to that user. And then we have time-based login. Pretty simple, setting a restriction on when a user can log into a system. Maybe you do this for work hours, or maybe for the obscure hours like midnight to 6, they won't be allowed to use their credentials. Some more account policies. You can also implement a security setting that only allows access to a resource from a specific system on the network. For example, suppose you log into a computer in the accounting department, but are trying to access resources in the human resources department. In that case, you can set a security policy that will not allow you to access the human resources, even if that user is a part of the human resources department. So let's break that down a little bit. So let's say we have our accounting computer, and that's on VLAN 20, and it has its own GPOs assigned to it. And then we have our marketing computer here. And then Bob, who's a part of the accounting department, goes to talk to Sean over here, and he's like, hey, let me log in and show you something. And he tries to log into this marketing computer and tries to go into his accounting resources. If we set a network location policy, we can put a GPO that says only computers in VLAN 20 can access the accounting file shares or SharePoint portal pages. So even if Bob's user account does have the correct access, if he logs into a marketing computer, he won't be allowed to access those accounting resources because he could be showing Sean something he doesn't need to see. Impossible travel times will compare log data of where a user logged in and at what time. So if a system says user 1 logged in at 9:04 a.m. in London and then logged into a system at 9:07 a.m. in New York, this is a sign that user 1's account may have been compromised because the user can have been logged in at the same time in two geographically separate locations. So this is just a term to describe or to help you notice when an account has been compromised by looking at the login history. Some more account policies. So, account permissions define what an account is allowed and not allowed to access. This will typically be set by organization security policies and guidelines. And then account audits verify that accounts throughout your enterprise have correct permissions for their daily roles and duties. You must always trust but verify that your team is setting the correct permissions on user accounts. Lockout is a security policy that you can implement on your user accounts that will lock out a user if a password is entered incorrectly a certain amount of times. The typical standard you see is 3 times. And once an account is locked out, a user must contact an administrator to unlock it. During this process, the administrator will be able to determine if the authorized user is locking out their account or if someone is trying to brute force that user's account. Disabling an account will not delete an account, but will prevent an account from being used on the network. If a threat actor has compromised an account, the best thing to do is disable the account, not delete it, so that you can still perform forensics on the account later. All right, so that is all we have for this video. I want to thank you for viewing and join us for our next video. We will go over domain 3.8, authentication and authorization. Thank you for viewing.